So then let's start with the first program point. So our first keynote speaker of today is Philippe Coval, and I'm just checking where my phone is for his CV. So it's my greatest pleasure to welcome Philippe aujourd'hui and today. And Philippe is a professional open source engineer who has been supporting the FLOSS community since the late 1990s. Over decades, he has contributed to many projects from operating systems, Debian and Tizen, to IoT frameworks, IoTivity and web things, and more. He also advocates for FLOSS at various occasions, FOSDEM, ELC, etc., or shares proof of concepts online. Currently, he's contributing to the Oniro project, and he's always open for potential collaboration, and you find his contact point also in the agenda. And yeah, Philip, it's a great pleasure to have you here. I will show the brief trailer and then say something to the Slido, and then I hand over to you.
I'm going to explain how to rebuild this vending machine blueprint, LED matrix, Raspberry Pi, I2C touchscreen, USB. If the user press buy or order button, then we are simulating the item preparation.
And as usual, we have the Slido, so please ask your questions over the Slido. And as I said yesterday, it's always good to have a couple of questions after the presentation, so it would be great if you already think during the presentation what could be an interesting question. And as free and open source software is a topic that really touches every one of us, because we are using it very often, and hopefully some of you are also contributing. I'm sure that we'll have a very interesting discussion afterwards. And that said, yeah, I hand over to you, Philippe, and we're looking forward to your keynote, and we welcome you with a warm applause.
Thanks everyone, and it's been a pleasure for me to be here, because maybe 20 years ago I was my first job was actually at ERISA, and now I'm back explaining what I learned about this year. So today I'm going to explain about this Oniro project. And first, let me introduce myself. So as I said, I'm a software engineer. So I'm based in Rennes, and I'm working remotely for different organizations. And currently, most of my time is busy with Huawei Open Source Technology Center, which is a European team based in a decentralized environment all over Europe and elsewhere also. And I'm also consulting from this Astrolab company. I've been involving into many open source projects, mostly operating system, but not only. I've been also doing some contribution to community side, of course, and also in industry supported projects that are shipped into consumer electronics, for instance. And I've been involved into IoT project, but I will not speak too much about IoT today. I will more explain about software stack. And I can say I'm creative mind, because I try to make a lot of proof of concept and explain this to various occasions, like conference and so on. So I shared some demonstration tutorials and videos you can check on my website. So today I'm going to explain my prototyper background, because that's something I want to share, and it can be interesting also for students or young engineers who want to try to get into this industry by doing things. And I will explain the role of open source in prototyping and doing proof of concept. And I will explain how the Oniro project can be useful to you. and then we do some wrap-up. And I can handle question in French if you want. So, as I said, I was an engineer in year 2000 at INRIA. I work on 3D hybrid video coding. That's something was quite interesting. It was about valorizing some academics works. So basically, it was making a showcase about explaining how can this technology can be useful. So you can explain it in 1,000 slides or just show a demo. That's a different approach. So then I work on similar project to other labs like Orange and then Technicolor as well. And I work also in startup and into big industry players. Mostly I've been involved in the software side, but I've been playing a lot with hardware, about integrating software on hardware, having to sometimes to play with iron soiler or something like this. So I'm a DIY person, and I act many proof of concept or some fun demo I made, like a Linux pinball home. And I've been also hacking in local communities like this CampOSV, which will be presented after lunch by Guillaume. So you'll be curious to know what is this project about. And here is a short demonstration. So this is one example of the prototype I built. And so this is an open source vehicle. So it's an electric car, and then on it we used to have some time to do some hackathon on this and trying to play with the communication network inside the bus and so on. But unfortunately, last time it was not possible because there was some COVID restrictions. So I proposed to try to do something online using a VR environment. So for this, I've been using this Hubs project from Mozilla. So it's a shared environment where it's a multi-user environment. So it's like video games, and several people can interact and chat and also do some talk using voice inside this world. So it's running on the web. And so users can also import some assets. This means you can import some file. So we made a model of this open source vehicle. So by importing the static file, you can just add this model inside the world. So that's the flexibility of it. So this new item is shared among different environments. So that's pretty cool. This means you can co-build something. You can adjust the properties value, and something that can be interesting is that even if the platform doesn't have any API to interact with the world programmatically, using this JavaScript act, you can get access to some projects. And for instance, here I'm showing the scale of my last item has been inserted in the world, so I can dynamically also change some properties of this object in the VR world. So if I'm changing the scale by 15, for instance, it will scale up to 15, and it's replicated into different client of this shared world. So if we can do it programmatically, this means this is opening some pretty cool opportunities. So some objects can move the assets inside the world by just pointing and relocating and so on. You can also insert some interactive objects like a camera, for instance. So I'm showing this in a second. So it's using a WebRTC stream, and then I have a webcam which is just above my hand and my mouse. So I can move the object, of course. And what I'm going to show you is how to merge virtual world and reality. So that's a bit hack. It was fun to do. So let me show you. So I can just move this object to make it more visible. So I don't have this electric car home, but I made a toy using Lego to simulate this. So what you have next to my mouse is my plastic car, which is a replicate of this electric car. So on this, I have embedded a development board, which is a Freedom board from NXP. So it's not a powerful system, it's a microcontroller, but on it I'm using some operating system, which is made for real-time. It's a real-time operating system, but for microcontroller. So I can select this board, And then I wrote some drivers to under some onboard sensors. So here I'm showing the configuration part. So there are several sensors supported. So I wrote a driver for this one, which is specific to this board. And then if I'm rebuilding the system, I can run this. So here. So it looks like it's actually it's very similar to a Unix system, but it's not a Linux system. It's a microcontroller, and they are trying to align POSIX API. So here is our sensor value. So there is an accelerometer and a compass, which indicates the magnetic, the north. So once we have we are handling this sensor, we can do a lot more and then connect it to the outside world. So the magic of Unix is that you can create some abstraction, and you can pipe one program to another. So for instance, here I'm writing the output, the real-time output of my sensor to a FIFO file, which is not a file, it's a device. And then if I'm connecting my device to the network, because it's using a Ethernet adapter, then I can decide to send this output to the outside. So I have one process which is producing the information, and the other is just consuming it and sharing to the outside world. So like I did just before, we can decide to update some properties of the virtual world by coming from the real world. So here I'm sharing also, like I did before, just pasting a JavaScript, which is using WebSocket, and it will connect the sensor stream to the actual virtual object. So here it goes. So it's slowly oscillating because I didn't do some filtering, so that's something that a contribution that can be useful. But it's moving in real time, so what you see on my camera is the same show in this 3D representation of the device. So that's the concept I've been exploring about digital twins. That's something that's not a new concept, but I wanted to make sure it can be possible today using open source technologies. And I shared this last time, and everything is more or less documented. But yeah, you can have a look. That's something can be fun to do. So why are we doing some prototyping? So usually, in my case, I'm a very hands-on person, so my patience by reading documentation is a bit low, so sometimes I need to try to see if that's something useful to me. So I'm a very hands-on person, and to test or evaluate the maturity of a technology, in my opinion, the only way is to try yourself. And if you cannot get some good results fast, so you have two problems. Either it's you because you're not very good, not enough skilled, or either the project is not yet mature enough to be accessible to everyone. So that's a good way to learn and evaluate. And if it's blocking, that's pretty interesting because you have identified a problem and you can try to fix it. And as I said before, valorization of technology is something that can be pretty efficient by showing something actually working. So the proof of concept is pretty self-explanatory. You don't have to explain too much about what can be done because you are showing the things. So sometimes it's not very reliable, but it should be reliable enough to understand at least the concept. And often it's done in a rush. This means you don't polish too much your code, and you are aggregating different parts for different places. So that's something you need to stabilize over the time if you want something to be stable enough. So so yeah, you need to focus on something specific. There is no need to try to reinvent the wheel and just try to isolate something which has some value and try to see if you can spend most of your time on this and not recreating something that has been created before. So here, open source is coming into the place. As I said, you should not reinvent the wheel. You should try to reuse what others have been doing. Sometimes it can be effort costly because it's not obvious. Sometimes it's faster to recreate something from yourself, but you will probably do the same mistakes that others fix. So it's good to learn from the others. Of course, there is a code you can use, but also the documentation and the tools, because if something is shared, then probably there is some feedback from the community, and also something important. That's open source project most of the time are supporting some hardware which is very easy to find. So that's something, so you have a reference system where you can replicate what the developer has been shared and what you can do your side, so you are on a common base. So that's something important. If you need to buy a board which is pretty difficult to find and there is different versions, then you could find some issue and you cannot, they cannot be replicated. So of course there is open source without community is not open source. So you have a community that can help you. You can report some issue. You can show what you are doing with the software you're using, and listening to the feedback can be valuable because there is probably other doing something similar or something that can be reused. And of course, contributing back to the project is something valuable in the long term, instead of just taking and picking and just having a free rider attitude is not paying off in the end. So even if your contribution is very small, like fixing a typo in the documentation, that's your duty, I would say. So licensing matters. So you cannot, it's not Far West. You don't have to take code and just put it inside your code under a defined license. You need to learn at least a bit how you can mix different pieces of software and align to the author decision. So this means you have some duties in terms of licensing. Okay, so we can aggregate open source stuff, we can show demos, but it has some limitation because software is moving. This means open source projects are never finalized. There is always some correction, fix, new feature, and so on. So you need to catch up every time, and someday or later your demo will break because you will not run on the latest version, and it will just not work. So there is a maintenance effort. That something can be done on your side, but it can be also shared. If your project is open source, or if part of the base of the project is open source, this means you can do this maintenance effort also. So something which is not working in long term, so you can make a prototype, show it, that's fine, but most of the time it will not go very far because, okay, you are shipping something and you're forgetting or archiving your code and nobody will be able to build it again. So in this situation, I can suggest to transfer to some. So there is a project called Abandonware, which is a collection of unmaintained open source software, and if the community wants to do some maintenance effort, they can try to do it by in a safe way, I would say. So maybe from the prototype you want to build a product out of it, so we are going to the industrialization phase. Some recommendation I can share. So making a prototype or product usually doesn't really work because you have a technical debt. When you are prototyping, you just want results. You don't think about the lifespan of your project. So the first recommendation is try to isolate the value. What makes your prototype this different? Where is the smartness in it? What is thing you made and nobody did before? So you need to isolate the value. Try to address this, identify the problem. As we say, a problem well identified is half resolved. And then you should try to split your prototype into different pieces and try to see which pieces are generic. This means that there is no specific value, so it can be shared. So in this situation, you can just upstream. This means find an open source project and adding a contribution that is very helpful for your prototype. So for instance, in the demo I shared before, I made a driver for this development board. This is not specific to my prototype, and if I decided it would be okay it would be better to share it to the community. This means that if there is some new version, it can be improved. And then if I'm rebasing on the latest version, I will have this feature still working. If I'm keeping it for myself, this means on each version of the software, I have to port my existing drivers, so it can be useful to be shared. So what I can suggest next is to find a project where you can put your contribution in, so it should be sustainable. So what I said is there is this maintenance job done in a community way. So when I'm saying community, I'm not saying that other will do the job for you. You are expected also to do it. So, but it can be easier for you to focus on this specific feature and only on this open source project, and don't care about your prototype. What you want, for instance, is this driver to work. So you can just work on the driver on this open source project. And something that can be valuable for the life of your product and your project is to make sure you are on the latest version of where all the security fixes are done, because if you're working on a frozen version of the software which is not yet maintained, maybe there is some security issue, you have no idea and you will find it out later. So trying to align to what this upstream open source project is doing is a good strategy. So I'm talking about now the sustainable platform, how I can define it. So it should be open for sure. And when I say open, this is open source, of course, but also open development. This means that there are some projects we are claiming to be open source, but they're only sharing the code and all the development and decision, and the contribution model is internal, so that's not something you can be part of. So that's something to be considered. So the reputation of the project can be useful if the project is contributing to other open source projects, because as I said, all open source is just a combination of other open source. So if the project you are getting part of is community friendly, that's a good sign. Now something more technical, the project should be technical developer friendly. So this means that you need to find at least some supported hardware. The tooling should be enough documented and useful. So when I'm saying about the quality of tool, I'm not talking about rich IDE and so on. I'm talking about having proper ways to build the software. This means can be command line interface. That's perfectly fine, but at least it should be reproducible. And something that is really important from the industry is about the maintenance commitment of the project. So does the project want to provide a long-term support? This means will they fix security policy? Is licensing well handled? This means that if you are using an open source project which is not complying to license, then the problem is also going to your side. So you need to make sure that the project is very careful about this. And reproducibility, this means you should be able to build a software now or maybe in 5 or 10 years if a customer wants you to add some specific change or do some security fixes. You don't need to fight to rebuild what you've done maybe 5 or 10 years ago by somebody else. So let me now introduce this Oniro project. So it's an open source distributed operating system. We are targeting IoT devices. And one goal is to defragment the development for embedded system, because it's a mess. There is so many different platforms, there is so many devices, so many vendors, so each of them are somehow addressing the developer needs by providing a solution. But often we have same in the consumer electronics, there is a bunch of silos. This means you need to learn a tool for a specific device, and if you need to change your device because you need some kind of feature, you need to take another tool with another API, and it's really costly. So this is what we try to do, is to find what are the common denominator between all class of devices and try to address some common problems. So we are not making a system that will run on a microcontroller or on a super powerful Linux system. That's not the goal, but we want to have something common between those cases. So when I'm talking about IP licensing, for instance, the code you put on a microcontroller or on a CPU is also subject to the same rules. It should comply with the legal requirement and so on. So we want to unify this, having common policies and make developers' life easier. So let me introduce also who is Oniro. So it's an independent Eclipse Foundation project. It's all open source, so you can get it on online. So, and the decision is made inside this project by a working group. So it's a vendor neutral project, and we want also to make it compatible with Open Harmony ecosystem, which is led by another open source foundation, which is Open Atom in Asia. So it's Maybe there's other, but it's one of the few projects which is doing collaboration between the western side of open source world and the Asian, also Chinese in this case. So what is the platform? So it's based on a solid open source project. We are not reinventing the wheel. We are reusing what's best on the market, on the community, I would say. And we try to fill the gap for our requirement into the project. So today, it's the whole framework is multiple kernels. This means it can run on a CPU, on a microcontroller. And we are trying to have a common build system, and we are reusing the BitBake tool from Yocto or OpenEmbedded. And we believe that having this build system is also providing a point of convergence for many projects. So that's something interesting in the long term. And of course, we are committed to have best practice in terms of legal, security, and privacy. So here is the promise of this Oniro project. So it's a multi-layered architecture. So the core is the kernel. Then we have some system services layer where are some specific Oniro feature talking about cooperation between devices and some kind of cooperation and communication feature. And then we have a framework layer for people to create SDK to create applications. So it can be native or choosing some scripts. And then you can host several applications. So now let me explain how it is today. We are just about to release a version. So of course, you need to run it on hardware. So the project is flexible enough to support different range of hardware. Today we are working on ARM CPU and Intel, and also on microcontroller like Arduinos and something like this. So to support one specific hardware, you probably need a board support package. So that's something not from us, but usually coming from this hardware vendor. So for instance, we are using a single board from Seco, which is a partner of the project, and they are providing all the needed bits to support their hardware. So it's called Meta Seco Intel. This is specific to BitBake. This project is containing a kernel. In this case, it's a Linux, but if it's another board support package, it can be Zephyr or something, other operating system. And if you are working on one, maybe you can add it to the project. And then we have this CoreOS framework and services, which are into a layer called Meta Oniro Core today. And this means basically the user land, which is running on the kernel. And then we have this blueprint concept, which is what I call the product value, which is in another layer. So today we have a couple of blueprints, so I will explain in details what are blueprints. So we made some, let's say, minimal viable product, so it's prototype trying to show some feature to do the final integration. This means that if somebody is wanting to build a product like this, he can just reuse it and deploy to some hardware, and it will get the features, the product somehow. And we wanted to make it the easier possible and the most reproducible also. So this means that there is it's not much complicated, but we want to make it easy and predictable. And also it can be a base to get some inspiration. If you want to build a product which is similar to some of the products we are sharing, you can just try to have a look at it works and eventually adapt it and or just reuse what has been shared. So today we are sharing a couple of blueprints. Like we have an IoT gateway, which is supporting the thread network, mesh network. We have this vending machine prototype, also a door lock, and also a keypad running on microcontroller. So let me show one example about this vending machine. So basically, it's a display where user can select some items, and once it's okay, it can confirm, and then we are simulating the preparation of the item you order by this LED matrix. But in real life, you should probably control some motors or some actuators that will make inside the machine. So we made it easier it was easier for us to simulate it, and also for developers to test the software. That's no need to have a lot of hardware to test it. So it's running on a Raspberry Pi. You can get a widely available screen. And once it's booting the system, it will just show the UI. So now talking about how does it work. So we have a user application which is running using LVGL framework, which is a UI toolkit made for microcontroller, and we've been using it also on Linux. This means that this application can be run on a Linux system, here a Raspberry Pi, but it can run also on a microcontroller. And we have another application, which is a controller application, which is just handling the LED matrix. But it can also handle something more specific. So we have two applications communicating together in a local environment. So this is IoT because it's using IP network, but it's not connected to the cloud or whatever. This is working in a container network, so that's, I would say, safe in terms of privacy or also robustness. So to get started and to rebuild this, that's pretty easy. You need to download the latest release of Oniro project. So I'm not sharing all the details, but that's all the principal steps. So you need to look at the documentation, and once you have downloaded all the code, you can rebuild the whole system using this bitbake command, and then you have the basic operating system, which will boot a login string. And then, if you want to have this product-specific code, you need to clone an extra layer, which is a blueprint layer, and then add to the environment this specific layer, and then you can rebuild an image which is specific to this layer. So that's pretty easy. You have at least 4 different steps. The 2 ones are generic. The second one can be internal, or only belonging to your project. So that's nothing. It can be shared to the community if you want, but it can be also kept in private. That's a modularity of the project. So hardware support is something important for us. Also, you can do some development using a QEMU virtual machine. So that's pretty easy. It's been, every developers can run this on their system, so there is no need to get some specific hardware, or deployment can be easier. For demonstration or validating feature, you can use a community board like a Raspberry Pi, Arduinos, and many others. And even if they're not supported, we can deal with this. If you're making a product, now probably you will have to find a partner which is providing you this hardware reference design. So, and then you can decline this base to a specific project and do some production. And today we are supporting Seco B68, so it's a single board computer. And also, if you need a specific hardware, if they are providing a Yocto layer, this means you can also just change the hardware support and rebuild the system, and then it should work. For instance, there is one for Raspberry Pi, but there is many others. So now let's talk about our policy and commitments. So it's open development. This means these problems are discussed in the open. We are doing continuous integrations. Each change are being validating by our build system, and we are testing it also, and we are regularly scanning the compliance of the code that's getting inside the project. This means that we want to do the verification before than after. So this means that we are sure that the whatever gets into the project is legally matching the project requirement, and also we are doing some security scanning and fixing. That's something we want to address by a security team. Also, we have a feature to provide software over the air. This means that if there is some security fixes, it will be fixed inside the base, and if your product is continuously updating, it will get this new feature, this new fix updated in real time. Tooling is something we want to improve, make it consistent among different environments. And we are community friendly. This means that we are not trying to redo what others have been doing before. This means that we are reusing things coming from the Linux world, Yocto, embedded distribution, Zephyr from microcontroller, and OpenHarmony from other feature. And if we want to make some fixes, we don't make them only in our project. We want to fix them in the sub project we are using. So basically, recently I made some patches for Yocto project, and I prefer to share them to the Yocto project first. And once it's before it's integrated, then I'm making a copy inside our project. This means that if I'm following the next version of this Yocto project, this patch will be integrated, and I don't have to maintain my side. So to join us, it's open source. You can get the code and share some feedback. We have different channels like chat rooms and bug trackers and mailings and so on. Collaboration is done under this open foundation, open governance. So you can join and if you want to be part of the project. And this open source, this organization is having a working group specific for Oniro, and then you can take part of the decision and try to push for a new feature, discuss, get feedback from the others, and also get other benefits for joining the project at the decision level. So yeah, the main address is Oniro project. So here, a quick summary. So prototyping, it's always fun. It's very inspiring. It can start easily. You get a lot of idea, but someday you have to stop, because if you keep doing this, it will never be a success in terms of commercialization and so on. So you have to shift to a different mindset into trying to stabilize or industrialize a product, and that's something can be harder. So my recommendation is to try to isolate the value, what make this product useful, and try to externalize somehow all the unuseful value and other open source projects. So you need to rebase on open source platform. And Oniro is trying to provide this. So it's a vendor neutral open source operating system for next generation devices. So that's something very flexible to try to address many use cases. If for some reason Oniro is not matching with your requirement, I'd be curious to know why, and we can discuss about it. So the requirement of today's industry is mostly IP compliance, of course, because it can cost a lot of money if people are shipping code they don't really control. Security is something really important, and that's I would say the critical in IoT, because that's pretty cool to connect everything, but if you're not taking into account security, and that's the main topic of this workshop, so that's we are aligned on this. Tooling is something important, because to invest a new technology, there is a learning curve that has cost also, so having tools that can be common between projects, that's something can be interesting from an industry or a teamwork perspective. And then we want to provide the full control of the shipped softwares and make it flexible enough to match different requirements. So it can be in terms of hardware or also of software. We don't want to enforce specific bits. We just want to build a common base that can be useful for any purposes. So yeah, I can share some resources, and if there is some question, please ask now.
Perfect. Thank you very much. So maybe I start with the first question. So it's a little bit more general question. So how did you end up in open source development, and who is your personal open source development hero?
Heroes. How did I came into it? I think when I was a student, and even before when I was a teenager, I was quite interesting into my computer was an Amiga platform, so it was not open source at that day, but there was something I really find interesting. It's the community aspect of computing. So Amiga makers, Amiga demo makers and shareware authors were very creative, and they have this kind of network of sharing all the software and knowledge. We have some like e-zine at the time, so tutorial explaining stuff. So I came into community before I knew about open source. I didn't really understood what was really open source, but this community aspect was quite, it was very inspiring, because yeah, alone you don't go too far, so having people around you stimulating you and sharing, that's something very valuable. And then when I was at university, I discovered internet and Unix at the same time, and both were very influencing on me. So I understood that in Unix system everything is open, let's say. So your limit to learning is there is none. So you can always, if you're curious about something, just find some source code or just either files, and then you can get some into it. So this idea of having no limitation by openness was very, it has a strong influence on myself. And I think I use Unix at university and my Amiga at home, and one day some guy called me and said, hey, you can run a Unix system at home, it's called Linux. So I said, oh, okay, so I can use a PC without Windows, that's interesting. And then I dropped my Amiga and hooked into Linux. So I've been using it so it was not easy the other day, and so, but it was very interesting because I was a computer science student, so I learned a lot by looking into the internals. And I've been using it for years, and I realized then this whole open source and free software movement, and I realized that I should somehow give back to the project by trying to do some contribution. And I think the first project was a Debian distribution. I thought it could be another project, but this one was, I would say, in those days, I thought it was a sane community. This means open governance and so on. So I decided to join and make some contribution, and then by making some contribution, I found some credibility somehow, and from one project to another, I've been involved into. But it can be, you don't need to be a hero to be part of it. You don't need to only spend a little time and trying to understand, trying to also have some good relationship with community from people from the outside. So it can be a bit frustrating sometimes because you have the impression that everyone is against you. Nobody has any time to give to you, like if you're not welcome here. But you can understand that the scale of this project, there is time is very important. So sometimes you can not really understand why people are not giving you feedback to you. Probably they are busy on something else. But if you do some persistence, it works. You just need to have some patience and to not make any assumption about why nobody is responding and so on. And my heroes, I don't like to personalize this because it's a world movement. There are some people who have a very strong influence, but those people alone will not go anywhere. So it's a shared result.
Good.
Yeah.
Perfect. Thanks. Very, very good. Do you want to moderate the questions?
Yeah, sure.
Perfect.
So we have some questions in the Slido as well.
Maybe start with the audience here.
Okay, do you have any questions? Sure. If not now, you can also think in the meanwhile or get inspired by the questions. Let's maybe start with the first one immediately. Is Oniro easy virtualizable, meaning that able to be run as a VM in a normal VM workstation like VMware or VirtualBox, unlike Yocto itself?
Okay, I think I answered this question, but I can make some comments. Yocto itself can be run on a virtual environment for sure, but we are using a QEMU system, which is an open source project, which is widely used in many projects. It's emulating different virtual machines from generic ARM devices, but also, there is a lot of architecture supported. It may be not as user-friendly as a graphical environment like VMware or VirtualBox, but I think there is other projects that can provide user UI. And it will not surprise me that the generic image built for x86 can also run on VirtualBox. So yeah, I will answer that definitely we are supporting virtual machine. But it's not a VirtualBox, and VMware is not a recommended way, but I think it could work. Yeah. And I know it should work because I worked in the previous project, and we were at that time using VMware graphics acceleration, which was only available on VMware, and it worked. But this is not a reference system, and the reason we are using QEMU also is that this project can be rebuilt within this Yocto project. This means that it's easy to replicate. Maybe someday VirtualBox will be part of Yocto project, which is not the case today, if I'm reading correctly the question.
A question from my side. What is the relationship between Open Harmony and Oniro?
Okay, so Open Harmony is a project initiated by Huawei is behind this, and it has been also transferred to this Open Atom open source organization, and it's also an operating system which are trying to address different cases. So I cannot explain too much into details, but if you look online, you will find some video explaining this idea of heterogeneous communication between device and high-level services like synchronization of content can be moved from one device to another. We can have also some kind of organic way of communicating between device and some seamless integration, and so that's something which is been shared by this Open Atom Foundation. The code source is open source also on Gitee, so this is a Chinese repository for open source code, and we are trying to rebuild everything we could inside our own Oniro project, which is on a different base. And so we are using Zephyr or other components from the open source. We are also looking what can be the value inside this Oniro project. We can also run onto this. So I would say that we are client of this Open Harmony, and one of our goals is to make it compatible with the standard that has been used in Open Harmony. And something also interesting that there is so many differences between the two projects that it can be really interesting to see if there is some kind of convergence somehow. So I'm talking here about tooling. We are using different build system and trying to unify this in a common way, which is used already from open source and also matching a big industry requirements. That's something that would be a very nice contribution in my opinion.
Questions from the audience? If not, maybe we can pick one last from the Slido, and then before we exhaust you with a lot of questions, maybe the first one, like this, is Oniro used in production somewhere? If so, can you mention some companies or products?
So the project just started officially. It has been starting for a year, but it hasn't been released to public. I think it was 1 month ago at Eclipse conference, so it's a work in progress. We have some members already. There is some ongoing projects. I cannot speak for our partners, but yeah, the promise is to try to deploy to many devices as possible, of course, and also make sure it will be maintained in the long term. So for this, with a working group, is providing different level of I will not say subscription, but membership, and then you can benefit of very long maintenance. That's our duty. So yeah, in IoT, that's a big concern because there is so many devices on the market, and we have sometimes no idea about how will they behave in the future. So it can be a disastrous if we have devices that get hacked from everywhere, or some cloud system which is not running anymore. The device become useless and so on.
Yeah, yeah.
So yeah, that's one problem we try to address.
How many people is the working group?
So I don't know in detail because it's something that's just been kicked off. We have at least maybe less than 10 companies a part of the project already, but yeah, that's something being discussed now. And that's what can be interesting, is that we have different people coming from different backgrounds. So this means that they have different perspective and different interests of the project. So it's not something which is only led by one player. It's we are trying to reach a consensus about what can be useful, at least for the big players and for the smaller one. And everything is done inside this Eclipse Foundation.
Would you say open source has a future? I mean, it's a very provocative question, but the question goes more to explain it a little bit more into the direction. There's a lot of open source projects developing. There's also commercial projects developing. Do you think it will coexist? Will it more shift towards, or even more shift towards open source? Will it more shift towards proprietary software?
That's not a tricky question, but that's interesting because open source for the world free open source movement and so on started in 80, for instance, and over the years problems change. Now there is so much different paradigms. There is some lot of open source software running on the cloud level, for instance, which is coming with new concern. And something I didn't tell when I've been asked about Open Harmony and Oniro, something important also is that today there is some, I would say the relationship between society and computing is evolving, that we are trying to take into account all kind of threat and legal requirement and so on. So we have different, it's not like Far West like it was like 30 years ago. Now there is strong regulation, and for instance Open Harmony is trying to address the Chinese markets. This means specific requirements that will not work inside Europe and vice versa. So Oniro wants to address the requirement in Europe, so in terms of IP, patents, privacy, and so on, security. So there is a lot of rules and news are coming every day that we cannot work at global level. So that's a big challenge. So this is answering back to your question. So probably will open source was, let's say, borderless in the future. This code can move from one project to another without just by the internet. Now we are more into you can do some open cooperation without too much trouble, but for deployment, that's another story. We have to comply all the requirements, and you cannot do. One cannot decide for all. So we've been a lot of concern about social networks. We are trying to deploy on some countries. Some countries decide to ban them because it was too invasive. Others didn't want to prohibit them. So there is a lot of discussion. In my opinion, privacy is something I find very valuable, and that's something which is in the root of our open source community, because it's user-centric. So mostly the first user of this open source project is a developer, so he wants to implement the features that can be desirable for him. And if he's playing against the users, somebody else will come with a patch to revert the specific feature. So I think, yeah, we have a lot of concern nowadays. I'm not saying that we are in a Cold War or something, but there is so many different concern into computing and open source projects. That's a really good opportunities, because we are that's the value we are promoting from the beginning. So that's not only a promise. That's something that has been done over years. So I'm thinking about organization like Mozilla, for instance. They were trying to make a LC web, for instance. So they want to take care about user data, privacy, and so on.
Very good, very good. So yeah, also for you then the speaker certificate, and you also get our Future IoT bag filled with some speaker goodies.
Yeah, thanks everyone for attending. I know it was not easy to come, but that's good to see people.
And then let's also thank Philippe with a warm applause.